we go. Mossel, what's up, Mossel? 1K says he's gonna go eat. Cool. Jaden's here too. What's up, Jaden?
My man.
Okay, hopefully everything's loading correctly this time. But fucking sensation with the coffee pasta, dude. What's up, Sib? Also says, do you remember me? Probably. We have a lot of people on the stream here. I do recognize the name. When you say, like, do you remember me, like, do I remember, like, when your birthday is? Like, no.
No.
I remember you being in the stream at some point. I'll give you that. What's up? Sensation.
If they wants to talk like a bellend, they will be treated like one.
He is. Sensation enforcing good English for everybody these days.
Oh yeah, right. You see, this is the joke. If I'm getting it right, you got no fucking excuse.
Oh man. Yeah.
Just for all the American viewers, I grew up on what you would call the project, although less guns, but still the same kind of violence.
Yeah, what's it called? The county houses. County houses, right?
Council
homes.
As in local government.
Yeah. So like, I think in the U.S. we call that like
councils.
Like we call it the projects, right? Or like Section 8 housing. It's like affordable housing. It's like cheaper housing for poor people. Yeah.
And in those kinds of environments, everyone's poorly educated at best.
Yeah, at best. It's amazing they can even speak any sort of like English. That's like distinguishable.
They sound like that I just wrote.
Yeah. I am motionless. That's a proper lodging, scratching about like a narky muppet with no to offer. Oh my god.
Keep faffing and I'll bust the up so fast they won't know what's it there.
Oh my god.
That kind of stuff. So if I can get English correct, you haven't got a fucking excuse.
That is very true. Very true. Okay.
What are we up to today?
What are we up to today? I got a couple questions from people about, someone wanted to go over like the pillbox derivation for electric field between two charges. I can remember how that works. Yes, actually, I think I do remember how we're gonna do this. Yeah. Anyways, okay. All right. Let me see. What do we got on the docket today? In terms of announcements.
Who helped me with my?
Can you help me with my math? Yes, Sup. I can definitely help you.
Who helped me with the math? I can help you with your English first, though.
Sensation can help you with your English if you want. Yeah. But yes, Sup. If you need help with math, you know where to do it. You know where to submit the screenshots. I'm sure you've been here before, Sup. I know you have, dude.
I've seen the name before.
Yeah. Wait. I think what is Sup's name in our Discord? Sup. What's your name in our Discord, dog? These kids like don't have homogeneity between like their names and stuff.
Yaden.
Oh, it's Jaden. Yeah, of course. Okay, I know who Jaden is. Yeah, that's Zhongzhu. I know your Chinese name, dude. Zhongshu. Zhongshu. Okay. Let's see. I do have a question from Mistral. Mistral, you had a question you wanted to ask, right? A little physics question? I'll do a little physics question first for you. Let's see this one. Maybe solving it with Green's function. I think you can just use Gauss's law for this one, honestly, dude. All right, let's see. A system consists of a ball with spherically symmetric charge surrounded by space with volume charge density. Ooh. I'll make this kind of scary.
That changed it.
Find the ball's charge if the magnitude of the electric field is independent of R outside the ball. Cool. Okay. So, okay, let me draw some pictures. It's kind of a cool question. Okay, let's say this is the inside. They have to give me some dimension, right? Yeah, bounds of integration. Yeah, for sure, dude. This is physics, Zhongshu. It is physics. Physics. Actually, here, let's make this bigger.
Wait, Jongorima?
Jongorima? Well, actually, I don't think he's from China. I think he's from Indonesia or Malaysia.
Okay.
Yeah. I
can never remember who's from where these days.
Yeah, I know. We got people from all over the world, dude. International education. We should call that actual international education. Maybe I should go for the
feet.
Actual feet. That's our secret business model if all else fails. Just gonna start selling feet pics.
I still think that image was funny though.
Ooh, the Aura. Yeah, that's a great picture, the one you generated, Sensation. But ooh, the Aura farming boat kid. Yes, he's from Indonesia, I think. Yeah.
Oh.
What's up, Nick? Good to see you. Monzel says it has infinite density at 0. It doesn't. Well, okay, I guess it does technically. Yes, because the volume charge density is rho over r. But there's no volume there. Does that make sense? Because charge, Q is equal to, well, or whatever, like dq, right? Is equal to rho dv. So technically, there's no volume to multiply by an infinite charge. Yeah, sorry. What question is? I need to see the answer. I think this is missing some fucking information. Like, where is? I see like a big R here, but like which dimension does big R refer to? We are missing some stuff. What chapter was this in? What's up, Pink? Good to see you.
How do you even read that? Rho
Okay, I'll
equals
call on you.
alpha over radius.
Alpha over radius, yeah. Alpha over R, yeah.
Okay.
Yeah, alpha's a constant. It's in the Gauss's law. Yeah, big R is exactly, yeah, but I don't know which radius big R is. You know what I'm saying?
The bigger one?
The wording on this question fucking sucks.
Saying which one's bigger? The bigger one, presumably.
Yeah, I don't know. I feel like you need different R's here. Or maybe you don't. I don't know. Maybe I'm dumb.
Radius is radius, right?
Wait. This is question 12. Radius is radius, but I'm like, but which radius is which, you know?
Well, radius 1, radius 2.
I
mean, you're always doing that.
Oh. Is it infinite? Okay. It's surrounded by space. I see. Okay.
So it's a sun.
So it's a sun. No, I think big R is a radius of the small circle. And then, okay, what? Why is this not like on top? God damn. And then, yeah, I think I understand this now. Okay. This is such a funny question. Okay, I think this, guys, I think this is R. Right? And, this is like the space where rho is equal to alpha over R, right? Okay. And then they want to know spherically symmetric charge. Okay, so this has, let's say this has some charge Q, right? This thing has a charge Q. Uh-huh. And we want to find the ball's charge if the magnitude of the electric field is independent of r outside the ball. Okay, cool. So that means for a Gaussian surface somewhere in space, right? Space is the orange land. Sorry, this question is worded weird. I need the E field here to be independent of R. So I guess E is constant, right? So that would mean E times 4 pi R squared has to equal some Q enclosed over epsilon naught. But the Q enclosed has to be wait. Okay, oh, so the Q enclosed has to depend on R squared. Does that make sense? So if you do this, right? I know E is going to have to equal to 1 over 4 pi epsilon naught. And then it's going to have to be 1 over times 1 over R squared. But then Q enclosed, this needs to depend on R squared. Because if the charge enclosed depends on R squared, then we're Gucci, right? Then E would be independent of R. Rho does start at R, correct? Yes. So let's think about that. So charge enclosed, so Q enclosed is going to be equal to some amount Q from inside, right? And then plus... And then this is going to be integral of rho dV, right? But then that's going to go from big R, right? So we're going to start integrating charge being enclosed by the space as starting at big R, going to like some location little r. Coming out of the spherical coordinates? Well, no, the 4 pi r squared came from this. This came from E dot dA. Yeah, integral of E dot dA came from this. That's
no,
where
I feel like 4 pi r squared has some particular significance.
It is the surface area of a sphere.
That's it.
That's what 4 pi r squared is. Yeah. Good eye there, dude. Yeah, no, it is. Yeah, that's where it comes from. Right. Okay. So now I know that rho depends on A over R, right? So watch this. When we're converting to dV, yeah, no, I agree. So here, let's try it. So I agree that, yeah, something's going to come out with this. So watch. So this is going to be equal to Q. And this is going to be plus the integral from big R to little r. Rho is now alpha over R. And then dV is going to be 4 pi r squared dr. Am I allowed to do that? Like, I'm just going to make like a bunch of like little surface spheres and I'm just going to like integrate them outwards, right? Curious how this is going to become independent of R though.
So isn't that true of any area though? Even in 2 dimensions?
Yes. Well,
you take your height and your width and then you just expand essentially to become a larger and larger.
Exactly, to become a 3D thing. Yeah, no, for sure. We're taking the 2D surface area and we're expanding the radius out slower and slower. That's what the dr here is doing. And that creates a volume. What's up, Shanks? Oh, I think this works out. I think this works out, guys. Watch. Watch. Okay, so then this is Q. And then this is going to be plus alpha. And then this is integral from big R to little r. Let's make these different things. Let's say this is 4 pi x squared dx. I don't want to use like the same variable here. And then this is also, well, okay. Here, let's do it this way, sorry. Okay. I will use, sorry, r squared dr, but I'm going to integrate from r to like, all right, fine, whatever. I'll leave it as r. I wanted to do like a, and then have this be like a, because this is really like at a certain position. I don't like this being the same as this. It gets confusing sometimes. You can use r prime. Okay. I like that. Let's do that. Let's call it r prime. I'm fine with that. That's a good idea, Mazel. Okay. 1 over 4 pi r prime squared. So then this needs to depend on r prime squared. Okay. And we're going to call this like r prime. This is why, for instance, they use ijk instead of xyz with vectors. Okay. So now we're going from r prime. So this will cancel with this. And then I have, well, here, we can pull the 4 pi out. We don't need the 4 pi. So 4 pi alpha comes out. And then I'm just left with RDR. Cool. So that's equal to Q plus 4 pi alpha. And then the integral of r is going to be r squared over 2. So then we're left with r squared over 2 from big R to r prime. Did I mess something up, Femvox? RDRR? Or is that a joke? Oh, it's a Simpsons. Oh, no, that's okay. You're okay. I like The Simpsons. I don't really remember much of it, though. Okay. Anyways, okay, so now we evaluate this, right? So this is going to be r prime squared over 2 plus big R squared over 2. Oh, I see what has to happen here. This is actually really cool. You're a pirate now. R. Okay. So this is Q. This is still an alpha, I swear. 4 pi alpha. This is going to be over 2. And this is going to be r prime squared plus 4 pi alpha over 2 big R squared. What an interesting question today. 2 pi. All right, sorry. Q plus 2 pi alpha r prime squared plus 2 pi alpha big R squared. And oh, it's minus, sorry. I fucked up. Right? This is minus. Because whenever you do bounds of an integral, guys, you gotta make sure you subtract them. Okay, very cool. I see how this works, right? Because remember, okay, this is my, what are we solving for here? This is Q enclosed. So in order for my original electric field that I'm calculating to be independent of the distance away, I need Q enclosed to exactly just have r prime squared in it. No other things. I can't have it have like a plus r prime squared, because then the issue is like when I do this divided by this, the r prime squared only cancels with this one. So I need, I'll get to it. So I need Q enclosed to have a single term with r prime squared on it. Here's what Q enclosed is. Okay? Notice that this is my goal. I want this thing to be the only thing left. I want this to survive. And I would like for this other thing to go away. Right? This thing is persona non grata. Like, I don't want this. Because if I can get rid of this and just leave this for my Q enclosed, we're happy, right? So, in order to kill this, that means that Q has to be equal to it, right? Because then they'll cancel each other out. So to kill this, you need Q to equal 2 pi alpha r squared. Okay? Rain, go away. Yeah. So watch. Q enclosed is now equal to, let's say, 2 pi alpha r squared. This is really cool. This is a really cool question, actually. I really like this. This is pretty fucking dope. Minus 2 pi alpha r squared. Look at this. These things go away. I didn't think this would happen at first, but it does. So now Q enclosed is equal to this. Sorry, my alphas are not looking very alpha-y today. They're kind of looking kind of beta. Okay, there we go. And then watch what happens. If I take this Q enclosed being that, and we go all the way up to what we had here, right? So now, and here, let me do this as a different color. Beep, beep. Now you get that E is equal to K, and then it's going to be this thing. Uh, 2 pi alpha r prime squared. Oh, let's use it. All over r prime squared. So now these things go away. And lo and behold, right? Now your electric field is independent of r prime. It just equals to 2 pi alpha k. Nice. That's really cool. It's pretty sick.
Well done! Well done!
10 out of 10. Thank you, Fem. Good. So Malzo poses a good question, right? He's like, wait a minute. Why does E have to be constant there? Okay. Because the charge that I'm enclosing is independent of R. Why is that? One second. Let's think why that is. You're just moving and canceling letters? Yeah, we are. I'm trying to think of this intuitively. So, charge density is alpha over R. So, as we get further out, we're enclosing less and less charge. Right? But we're enclosing... Well, we're still enclosing more charge, but the rate at we're enclosing... Oh, this is very cool, actually. Look at this. It has to do with this. Okay, so... E.dA, right? So you have... E times 4 pi r squared is equal to what? To Q enclosed over epsilon naught. So what that tells you is that as you're going further out, the rate at which you are expanding your DA, like the more surface area that you're grabbing, is proportional linearly to the amount of charge you're enclosing. Thanks, Sam. I'm gonna give me some water. Because now my charge enclosed, right? Is equal to 2 pi alpha r squared over epsilon naught. And so, yeah, and that's really cool. No, it's been like that, Nick. It's been like that forever. Right. So, in order for Q enclosed to match with that, right? I need this to like equal this. It's pretty cool, actually. It's because whenever you're calculating the charge enclosed just from the space, right? You're having to you're calculating like the total area, and then you're subtracting it from like the whole, right, to get the annulus, right? And so you're figuring out what this needs to be in order to like basically plug the hole. But then also like this charge density isn't linear. So, oh man, this is a really cool problem. Okay. But for Sib asks why is it Q plus? Okay, because the charge enclosed, Sib, is Q from the ball plus the charge you enclose from like the space. They're basically saying that like the air is charged. Right? They say, look, it's surrounded by a space with a volume charge density, so like the air somehow has like electrical charge in it. But that electrical charge is dropping as 1 over R as you get away from the ball. Which I don't know necessarily how that happens in real life. I guess you could have like water molecules or something in the air that are like holding charge. Gauss's law is so OP, it is. I feel like this is dope, dude. That's cool.
That's dope.
I've never done this problem in my life, by the way. Just tell you straight up, full disclosure. But I have enough faith in Gauss's law and my ability to like follow through on the math that it works out. Yeah, nice question, right? Yeah, very good question. Mistral, I really appreciate this one. This was a fun one. I'm glad I assigned it for homework. Honestly, I just assign what like they assigned last quarter. And then, you know, trust their judgment. But then I'm here to help, you know. Yeah. What's up? Sib's coming on stage. What up,
Hello,
Sib?
can you hear me?
I can.
Hi, can you hear me? Oh,
Yes.
okay, cool. Hi, Dr. G. Thank you. I appreciate it. I was a little bit confused with the variable of integration.
Yeah.
Because I see that sometimes that R is equal to R, and so the Gaussian surface radius is equal to the variable of integration, but then sometimes it's not. And so I guess is it if you integrate up until the Gaussian surface with the same R from the left-hand side equal the R from the right-hand side?
Yeah, so these are two different R's in this case, Sib. So, and this should have been like R prime. It's confusing, right? Because we're using so many R's in all the places, but technically some of them are different. So when I'm doing this, the area of the volume of integration is starting at big R, because that's the start of the orange space. The orange space is like a donut, right? This is a hole. When we're integrating the charge in the orange, we start at big R, and then we're going all the way out to some arbitrary R prime, where R prime is just some distance away from the center, but it's outside of big R. And then this R without the prime, this comes just from the dv integral for a sphere. So this is dv for a sphere. Is always just going to be 4 pi r squared dr. And then you integrate that from like some inner radius to some outer radius.
Okay, but is it ever the same? Like, is the Gaussian radius ever the same as? Like, can you ever cancel it out when you go in and you put it back into the Gauss's law?
Sure.
Is there ever a case where you can cancel out the r's?
Yeah. So you are right here. So the r here for like e dot da. Okay. When we do this integral, e dot da. This is usually also integrating from some starting position out to some outer position in order to get like the surface area there. Wait, actually, no, wait. Let me take that back. Let me take it back. Take it back. Okay. Okay. This is a surface integral. This is why this is not a volume integral. This is a surface integral. Okay. When we do e dot da here, yeah, e comes out.
Yeah.
And so now you just have the surface integral dA, and this is for a sphere that is located with a radius of, in this case, r prime. And so what I should have written here, and I think I did here, right? Yeah, this should be e times 4 pi r prime squared, okay? Because wherever I am choosing to find the surface area of my Gaussian surface, whatever r that is, that needs to be the same R that I'm calculating the charge that's enclosed.
It's the same one.
Yeah, it has to be the same one. So this here was E times 4 pi r prime squared. Okay? Because r prime is where I'm building my Gaussian surface area, right? That's a sphere.
Yeah.
And then I also need to calculate the charge enclosed there. And what I knew was, okay, well, if we move this over and we're solving for E, I need the charge enclosed to be a single term that is just dependent on r prime squared. So that whatever comes up here, the r prime squared in it will cancel out with the one below it. And this one came from over here.
Oh, okay. So in this problem, it is the same, or it's always the same. It's always the
Yes.
radius of the Gaussian surface. Oh, okay.
Yes.
I was confused about that.
No, I get
was
it.
asking
It's because it's two different R. You see all these R's, and you're like, wait, which R are we talking about? Right?
Yeah.
Yeah.
Oh, thank you so much. So it's always going to be dependent on the radius of the Gaussian surface, what we're integrating.
Yes. Yes. The charge you're enclosing will always be dependent unless. So here's an example case. Let's say, for instance, we had the same thing of. Yeah, make this solid. Okay. Let's say we have a solid sphere that's a conductor. Okay.
Okay.
And it has some charge density that's equal to alpha over r. Okay. And I want to calculate what the electric field is located outside of. Sorry, let's not make this conducting. Let's make this non-conducting. Sorry. So non-conductor or like insulator. Okay. And then let's calculate what the electric field is outside of the sphere, located at some distance. Let me call this like r prime. Okay.
Okay.
All right. So first off, when I go to build my Gaussian surface, that's going to be a sphere, right? That has a radius of r prime. So this is my Gaussian surface. And so when I write integral of E dot dA, that's going to be E times 4 pi r prime squared. Okay? Because that's the electric field times the integral of dA, which is the surface area of my Gaussian surface sphere thing. And that Gaussian surface sphere has a radius of r prime. Yeah?
Okay.
Good? Okay.
Yeah, thank you.
This is equal to Q enclosed over epsilon naught, all right? How much Q is being enclosed here?
That's... Oh, do you want me to answer?
Yeah. It's not trivial. I mean, you can't like really do it in your head, but you can kind of think about it, right? Where is the charge that it's enclosing when we're all the way out here?
It's still in the center.
It's just in the center, right? So this is where we write a separate equation here, right? Q enclosed. And we got to figure out, okay, how much charge is enclosed? Because I gave you a volume charge density, but that's only valid, right? For the part of the sphere that goes from here to like, let's say this is like capital R, like the radius of the orange sphere, yeah?
Yeah.
Okay. So in that case, Q enclosed, right, would be the integral from 0 to big R of 4 pi r squared dr, because this is going to be my dV term, and then I need my density, and my density was alpha over r, and then this was rho.
Oh, yeah.
Okay? And so what you see here, right, is this is going to get you 4 pi alpha, then you have r squared over r, so that's going to be the integral from 0 to capital R of just r dr. Good. This came out, these things cancel. So you have 1 r left. And now this is equal to 4 pi alpha, and then this integral is going to be r squared over 2 from 0 to capital R, which is now going to be 4 pi alpha over 2 big R squared. So this is just 2 pi alpha r big R squared. So this is Q enclosed. So we took like we took the volume charge density and then we like integrated it over the volume of the orange ball. Yeah.
Yeah, got it. And then you put it back into Gauss's law to see really what's the close.
Yes. Yes. So then this, yeah, Ethan, just give me a second. So this is 2 pi alpha big R squared over epsilon naught is equal to E times 4 pi R prime squared. R prime is like where you are outside the orange sphere trying to measure an electric field. So putting it all together, you have this. E times 4 pi R prime squared is equal to 2 pi alpha big R squared over epsilon naught. So now you can move this underneath. And you get that E is equal. So 4 pi will cancel out like with part of the 2 pi. So you get like a 1/2 here. And then this is alpha big R squared over epsilon naught. And then this is going to be R prime squared. So this is your electric field outside of the surface. Okay, what do you notice about this electric field? Is it constant outside of the orange ball?
Isn't it only if the R squared cancels out on top?
Good, exactly, right. Do you see how, so R prime, this is like where we are measuring E. Okay, so sometimes they'll write this. They'll say E as a function of R prime. Sometimes this helps people out because you're like, wait, like what am I inputting into this function? I'm inputting in R prime and I'm figuring out what the electric field is there. And yes, you're absolutely correct. So here, because R prime squared isn't getting canceled out by like Q enclosed on top, right? This Q enclosed is capped out. It's topped. As we go further and further out, we don't enclose more charge because the amount of charge is just there at the center. And so the electric field does depend on how far away you are. It does depend on like R prime, which is how far you are. Which is different than this one. In this one, we imagine that whatever, this space is like infinite. Like it just keeps going and going. And in that case, how we eventually got things to set up is that our electric field had the charge enclosed also depending strictly on R prime squared, so that canceled out the other R prime squared on the bottom, and now the electric field is constant. It never changes, which is pretty wicked.
Yeah. Okay, I get it. Okay, that's how you got R squared. Okay, thank you so much. I really appreciate it.
Yeah, you're super good. Yeah, of course. Yeah, always hop in if you ever want to like just like chat and just like get through things. It's a lot easier than waiting for the lag sometimes with the text.
Yeah, thank you. I can't really communicate with the chat sometimes for this because it confuses me.
Totally cool. You're all good.
Yeah, no, but thank you. Thanks so much.
You're welcome.
Goodbye.
All right. Yeah. Ethan, what's up? What's up, bruh?
Hello. Sorry.
You're good.
So yeah. I just like, how do I say it then? I was just out shopping and I got a cool new keyboard.
You got a cool new keyboard? You want to show us? What'd you get?
Yeah.
Let me see what Mistral's.
Hold on, let me show the face. Hold on. Let me just close my door really quick.
Mistral, yes. So the cases where the Gaussian surface needs to be inside the object. Sorry, I just went through the text chat. That happened, for instance, if you were calculating the electric field inside here, right? In that case, your Gaussian surface is inside the object. How do we know if we are measuring only inside or total inside the outside? Total inside the outside in the space. So here, as you're going further out, Mistral, there's no more charge. So you're outside, right? If you're measuring the electric field inside big R, as you go out towards big R, you keep like going through more charge. So your Gaussian surface is now enclosing more and more charge, which means that Q enclosed would then have to be a function of where you are. It would have to be a function of how big your Gaussian surface is, which was the case here. Oh, this fucking circle got too big, but whatever. In this case, let me move everything out or something. as you got further and further out, because the space is charged, you're constantly enclosing more and more charge. Oh, H, don't get mad at Sensation, please. He's a mod. He'll ban you. Okay, I'll wait for Mistral to see that.
No.
Okay,
I'll just go to his house.
I'll just go to his house and kill him. What's up, Ethan? All right, show us. What keyboard you got, dude? What's up?
I don't know. It says here it's like a KX250. See?
Ooh, nice. Looks like a Corsair. That's dope. Sick.
I'm trying to
Yeah,
figure out how to turn the. I'm trying to figure out how to get the RGB lights on.
Yeah, you sometimes. I mean, there's a manual for it, but like sometimes there's like some FN button or something you got to click on it. I don't even know if my RGB is working. There you go. There you go. Read the manual. Yeah, yeah. RTFM. Yeah, I hate reading the manual, but you do have to read the manual for these things. The funny thing is, if you start getting products from like deep mainland China, the manuals just get like more and more decrepit. You just can't understand what they're asking. Oh, nice. There you go. He's got the RGB. Sick.
All I had to do was to press the scroll lock key.
There you go. Yeah, there's always like some button you gotta press or something, or some key combo. Up, up, down, down, left, right, AB start.
I think I know that. I think that's like using games, I think.
That's the Konami code. It's the Konami. It's the code that used to like unlock everything. I think it was in Street Fighter. Who's old enough to remember that? What was it?
You've just described a Nintendo game, so NES. So
NES. It was an NES game. Yeah.
Like, here's the thing I wanted to ask about the games.
All right, what do you want to ask about the games? And then I gotta do physics. What's up? What's your question?
So you do it on Saturdays, right? What time?
So I'm not doing it this Saturday because I gotta go do wedding stuff this weekend. Which is why for the UCLA people, we're not having a lecture on Friday. We're doing a double lecture on Thursday. Because otherwise I'd have to do like super early Friday morning. I think we're gonna do chess this weekend, Ethan. I think I'm gonna let people like play chess like independently on their own this weekend, and I'll give you credit for just playing chess. And then next weekend, maybe we'll do like a doors competition or something. You did really well in the doors competition last time, right? That was fun.
No, okay, I have to tell you, ever since the new update, I'm just completely freaked out by the new update. Like
there is some weird stuff going on in doors for sure.
Like I'm just scared. Like, you know, the monster that comes out of nowhere and you have to look for it before
Screech.
Before you get in there.
Talking about Screech?
Yeah. It's like
Screech.
It's like when I would get in early game, he would be there and then he would do his psst. That doesn't make sense.
Dude, that stuff like messes with me, dude.
So that's why I'm looking all around my camera just to make sure that I'm not getting attacked by him.
Yeah, don't get attacked by Screech, dude. We could play Natural Disaster Survival. I have played that. It's an interesting game.
Okay, but there is also what else was I going to say? What time do you do it? What time do you do the things on Saturdays?
Usually in the afternoon. Usually around like 3 or 4 o'clock.
Alright.
HH says I uploaded 2 screenshots. Is there like a queue? I mean, you're probably the next up. Inverse Laplacian transforms. Uh-oh. You make me do Laplaces? Damn. Awesome. Yeah, Ethan, no games this weekend. Next week, I'll let you know. Just check the Discord. It'll be like 3 or 4 o'clock. And it'll be probably like 5 or 6 o'clock Denver time for you. Cool?
Alright.
Okay. I gotta go do some physics with some people. Or some math
That's
or
the question.
whatever.
That was the question, so.
Yes.
Oh, peace out for now.
Peace. You're good, dude. Okay. Waffle Walrus. Ooh, that's a good question, too. Scalar product. Yeah, I can go over the scalar product. That's totally cool, Waffles. Yeah. First of all, Nico. Oh, this one. Okay, bro. We did this one. I want to say we did this. This was a clicker question, Nico. I'm very sure it was a clicker question, wasn't it? I think this was like 100% a clicker question. Yeah. So, the things, I mean, the test is also like open note, open whatever, so you could have gone through the previous clickers and just found the answer. But next time. I get it that it's weird. You would think this is like QV equals QV. The issue is that, yeah, we talked about this during lecture. This is an approximation with, you can't use Torricelli's law here, but you have to consider that the velocity here is much less than the velocity here. Like, this is V1, this is V2. Yeah. I didn't think the hole was small enough to not be considered. Well, it said it was a small hole. Yeah. I know. But we did this one. Dude, this is verbatim copy pasted from a clicker question. So, you got to get that one. You got to get it. It's okay, Nico. Don't worry.
It's just this dude.
Which one? HHH?
He's asking me if I'm afraid now. It's like, of what? Of you?
What? You what, mate? You what? Swear me mum. Okay. Here, let me explain a scalar product real quick to Waffles. And then I'll do whatever HHH questions is. What is JJS? What if the hole was too small and surface? Yeah, okay. Yes, Aleph. That would probably mess things up too. You're right. I mean, yes. All of these are valid points. The whole point, but the whole the justification of that question is that like I already did it like during class. So just you should know all the assumptions we did during class. Okay, let me see if Waffle's around. What's up, quick Sarion? Awesome stream, thanks, man. Appreciate. Let's see if Waffle. I want to make sure Waffles is here so I can help him. Reki, what are you spamming my chat with, dog? Yes, nice, Waffle. Okay, cool. Here we go. The scalar product of two vectors A and B is written as A dot B, and it's defined as this. Okay. So, the way I like to talk about A dot B, A dot B is asking the amount of A that is parallel to B, and then like multiplied by B, or it's the amount of B that is parallel to A multiplied by A. Okay, so how I usually like to write this is I'll say, okay, this is like A parallel times B, or B parallel, or A times B parallel. So let's say, for instance, let's use some colors. Let's say like A dot B. Okay. All right. Let's say that A points this way, and then let's say that B points this way. Okay. So actually, let me make this one. Yeah, I know which way I want to do this. I want to do it this way. Okay. This is A. And then this is B. Let's do it that way. Okay. So if I want the amount of, I can think of this vector A, okay, as having a couple components, right? Vector A has an amount that is perpendicular to B, and it has an amount that is parallel to B. So if we were to draw the amount that's perpendicular, that would be this, right? This is what we would consider, this would be A perp. And then this amount here, Waffles, this would be A parallel, okay? See how anything in like 2 dimensions can be redefined as another like orthogonal coordinate basis, which is just big fancy words for I can define like the X and Y axis for something in like any rotation as long as X and Y are 90 degrees to each other. So I can describe movement in 2 dimensions by 2 other vectors. You see the vision? Cool. I can actually, sorry, these don't even need to be 90 degrees to each other. They could be at an angle, but it's just kind of weird. H, be nice, please, dog.
Just be very, very carefully. Right. I have killed more people than you have ever met. Leave me the fuck alone.
Yes, do not bother Sensation H, please. Otherwise, I give him permission to ban you. Okay. So if I want the amount that's parallel to B here, let's consider this as like an angle theta, which is between A and B, right? This is a right triangle. And so I could say that, oh, well, the cosine of theta is equal to the adjacent over the hypotenuse. And so that would be equal to A parallel over A, or really magnitude of A, right? So then magnitude of A cosine theta is equal to A parallel. And when you multiply that by the magnitude of B, right? Now you get A cosine theta times the magnitude of B, or the same thing, which is just A, B cosine theta. And it's super cool. I was actually using this earlier to find points on the globe that are given number of degrees from the sub-solar point waffles. That's cool. Correct. They just have to be linear independent. Aleph is true. Yeah. Yeah. The coordinate system you define just like can't be on top of itself. As long as it covers as long as the coordinate system isn't parallel to itself, then you're okay. And it also works the other way around. So if you wanted the amount of B that was perpendicular to A, right? You could think of, imagine like this just going out like slightly more, right? Then this right here, right? This would be like B perp. And this right here would be B parallel. Okay? So now it's the same situation. This is a 90-degree triangle. I gotta like rotate it. And then watch this. You can like rotate it around, right? And look, you got the same thing. Well, now it's like upside down. But, right? This is now B perp. This is B parallel. And so it's the same thing. If this is B, you have B cosine theta is equal to B parallel. Multiply it by A. You get the same thing. AB cosine theta.
My man.
Very cool. Yeah. Glad that makes sense. Yeah, parallel is only true in 2D. Yeah, we mainly deal with 2 dimensions. This is used in physics a lot because, for instance, and we did this in our class this quarter, but anytime you're talking about things such as like work in physics, so work is equal to F dot dx, and it's the integral of this. And so what it really is saying is that it's the amount of force that is like useful to your change in direction or change in position. Yeah. So basically, if you're exerting a force and the box is moving in the direction that you exert the force, you're doing work, which is great. But also, you know, let's say for instance something is moving in this direction, but you're applying a force downwards at like an angle. Say this is like your pushing force, right? The only work you're doing is related to like the amount of force that's useful for your movement. So in that case, if this is like some angle theta, right? You really only care about this amount of force. That ends up being like F sine theta. But for instance, if you were to extend this out, right? Then if this is theta, this is like 90 minus theta. And then the cosine of that is the same as this, right? Sorry, the cosine of this is the same as the sine of this. So like cosine of 90 minus theta is equal to the sine of theta. And this right here, so this is F perp is equal to F sine theta. So this is the same thing as, or sorry, this is F parallel, sorry. F parallel is also equal to F cosine 90 minus theta, and then you would multiply it by dx. And it's the same thing. It's F dot dx is, yeah, it's like F d cosine theta. Once you integrate it. Yeah. It's cool. Right, and then the cross product is the opposite of that, and that deals with perpendicular vectors. Yes. Hope that makes... Yeah, cool. That's good. Nice. Awesome. All right. Is HHH still here? Let me see if I can trick Dr. Gold doing a math problem following what I did. Yeah, let me see. I don't want to do Laplace transforms. Maybe this one's okay. Okay, HH, good. I'm glad you're playing nice. What's good, homie? Okay. Evaluate the following improper integral. Is this a tricky one? Is this gonna hurt me? Tell me right now if it's gonna hurt me. I don't want to get hurt. Suppose the sun. Okay. Okay, let's evaluate this. So, ooh. Do I want to do partial fractions with this? I don't think I want to, because this is like square root of x. It looks like arctan. Well, is it arctan? Let's go figure that out. 1 second. Yeah. Oh, arcsecant maybe. Oh, but ooh. I think that's u squared minus a squared. We have something plus and it's not squared. Oh, okay. All right. I'm just gonna let me just say u is equal to the square root of x, just for shits and giggles. So that means that u squared is equal to x. Oh, I think I see how this might work. And then du is equal to 1/2 1 over the square root of x. Oh, look at that. I love when du shows up. What up, girl? Yeah. Okay. So this is... I'm going to change my bounds later. Don't hate me yet. Alright, so... 1... Okay, so this is the same thing as just 2 du. Right? This shows up. Okay, so this is just 2 du over... And then this is going to be u squared plus 1. Right? This is tangent, I'm pretty sure. Yeah. Where is it? It's arctangent, isn't it? Yeah, this is what I want. Not tangent, sorry, arctangent. Yeah, okay. Yeah, okay, so the integral of 1 over 1 plus x squared is equal to arctan. Okay. So this is the same thing as 2 times the arctan of u. Okay. But now we got to switch our bounds. Okay. So now this is 2 arctangent of the square root of x from 0 to 1. Yeah. Oh, okay. That's not bad. So 2 arctan of 1 minus the arctan of 0. Yeah, right? Arctan of 1 is just, sorry. Isn't this pi over 4? You're asking what angle when I take the tangent do I get 1? That's when opposite and adjacent are the same. That's pi over 4. Oh, and then this is just 0. Oh, sweet. Yeah, it's just 2 pi over 4. Or pi over 2. Nice. That's actually a cool one. I like that. Nice. Dang, MZs. That was a cool one. We got lucky. So, I mean, this happens, guys, in calculus. This looked like really scary to me.
You gotta get in the hospital.
I was
now.
like, this is gonna be painful.
And I just said, just shut up and let me enjoy this pain.
But we made it like a guess. Like, when in doubt, just like say that U is equal to something. Like one of these things is equal to U. Like I could have said this is equal to U, but that wouldn't have helped out with the square root. But saying this was equal to U, I got lucky that taking du literally showed up what my thing was. Yeah, especially when the bounds are... Well, these bounds are finite. When they're infinite, yeah, I kind of like infinite bounds because then I know if I just get like 1 divided by infinity, I get 0. Like, it goes away. Yeah. You thought arctan was the cousin of tanh? No. Arctan is just tan -1. I could have written tan -1, but then people get confused that, for instance, like, they're like, oh, is tan -1 the same thing as 1 over tan? No. It's like, it's not. So, I don't know, I'll just write arctan sometimes. But yeah, if we can do your soon, let me see. I got a couple other questions from 1K. Are you here? I think I saw him in the chat somewhere. We got a nice little ChatGPT question here. I can recognize ChatGPT font. What do you think about SBU? I'm planning to transfer as a pure math major. In the future, I'll go for a PhD. Is SBU Southern Baptist University? What is SBU? Is that a school? I'm bad with acronyms sometimes. Oh, Stony Brook. Oh. Oh, is that like upstate New York? Stony Brook University? Oh, it is in New York. Nice. I think all universities and colleges are great. Femvox says Stony Brook is a great school for math. Yeah, I'm a West Coast person, so I'm not as familiar with all the stuff on the East Coast. But in general, like, the school you go to doesn't really matter that much. At least if you're trying to do things in STEM. What matters is what you do there. And I will admit that when you get to like higher level classes, like upper division, if you're a junior or senior, you want to maybe set yourself up to be at a university that offers opportunities for you to do really cool, like high level research. So for instance, if you want to study experimental plasma physics, you're not going to have the best time at like a liberal arts college because they probably don't have much money for a big experimental plasma physics device. Whereas, you know, like other schools like University of Wisconsin, UCLA, for example, for sure, University of Texas, they have money to like build these machines and then you can go do that research. But if you don't want to go experimental, like you just want to do like pure like theory, whatever, honestly, it really doesn't matter where you go. Because you don't really, all you need is a pen and paper, right? Or at least I think that's how you do theoretical physics. Femvox says, I remember seeing it listed as top 10 in the US for math. Yeah. That usually comes down to like who their faculty is. And like how much grant money they're pulling in. So yeah, another thing, yeah, especially for theory, because it's difficult to get money, but if you want to get paid for doing research, then you definitely want to go to a university that has professors that are able to secure grant money in the field that you want to do things. So I think for transferring, you can go to whatever college you want. Really doesn't matter, as long as you yourself do well there. So I say go to the university where you feel the most comfortable and you feel like you're going to succeed. But then for your last 2 years of college, I think it is important to go somewhere that lines up with what your interests are to do in graduate school. You can also like still go to whatever college you're at and then just make sure that you're collaborating or doing research with someone somewhere else that relates to what you want to do. And this is where I say that it's called REUs, Research Experience for Undergraduates. Just a little, so... Big fish in a small spawn. Yeah, what's up, Dr. L? No, REU for US. UCLA is number 7 for math. Don't we have Terrence Tao here? Also, like, fuck US News and World and Report, dude. This thing is such garbage. Hot garbage. UCLA is number 7. I mean, that's pretty cool. We do have Terrence Tao. He is kind of an absolute genius. Oh, we're above Caltech. Wow, look at that. Yeah, that's cool. And you're enrolled, dude. MZs, you're great. Then you already know what to do. Yeah, you're on a good path. I'll say the other undergraduates here that are watching, because I know I got some from UCLA. If you want to get research experience, this is the website to go do it. At least like over the summer, it's really good because they give you money and they pair you up with mentors, and it's really, really great for dipping your toes in the water to get experience with like what physics research is. And also it helps you lock down like really great letters of recommendation when you start applying to grad school. I got selected for one of these at Princeton for plasma physics, and then I went to Los Alamos, and then all of that kind of like spiraled into me eventually doing a PhD in plasma physics. But it was definitely because of this. I would say the REUs. I don't know what's happening with Trump and funding these days in the NSF, but if they still have money, you should go do that. So I'll dump this in the chat for other people that are watching. I'm glad you're already doing one, MZs. That's awesome. All right, let me see if 1K is not here. Let me do Ethan's. He's been waiting, and then Aleph. I will do your whatever Nightmare question is. And then Nick. We're gonna work with Nick too. Yeah, don't worry. I will help all you guys out. Ethan, what's up? You want to do your question?
Yeah, I'm here this time.
Wait, 1 sec. 1K just showed up. All right, 1 sec. Let me do 1K's. This take like 5-10 minutes, and then we'll do yours. And then Aleph, I'll take a stab at yours, and then Nick will do yours. Okay. He says I'm here. Okay, here we go. This is defined for all real numbers except where the denominator is 0. Great. Yes. You know what that's referred to? That's referred to as the domain. This is telling us that, like, hey, the domain is, and this is how they write it in fancy math language. They say x is contained in all real numbers, and then I think they do squiggle, but they say like x cannot equal. In this case, it's 2, right? So whenever the denominator is equal to 0, that's when x is equal to 2. There's another place. Yeah, Jeff already said it. Yeah. Technically, it's plus or minus 2, right? Yeah, because it's squared. Yeah, there's another place that happens. 2 and negative 2. Yeah, good job, guys. Yeah, exactly. Awesome. Okay. Vertical asymptotes, right? Well, the vertical asymptotes, this is also when you divide by 0. So divide by 0 means you're going to get vertical asymptotes. Almost always. I can't think of other times you don't. So, yeah. And then how they want you to write these, 1K, is you have to say this. You have to say x is equal to 2 and x is equal to negative 2. Oh, very good point, Jeff. Yeah, Jeff brings up a really good point. Yeah, vertical asymptotes. Yeah, sorry. It's where the denominator is equal to 0, but you don't also have the numerator going to 0. So here would be a classic case of, like, screwing up. If you had y of x was equal to x plus 2 over x squared minus 4, right? What you notice here is like, oh, okay, cool. Yo, I just realized you're the guy who showed me how to do Lewis dot structures in the fall 24 semester. Thanks, bro. Yeah, nice. Wait, you found me on YouTube? 1 sec. 1 sec. Sorry, I just gotta make sure. Yeah. Wait. Here, I'll find you my channel. Probably this one. Was it this? This is one of my most popular videos. Yeah, Lewis dot structures. Was it this one?
Here's an easier way to draw Lewis dot structures in chemistry. When you're given a chemical formula...
Yeah, I like this one. Nice. I'm glad the algorithm's working. That's cool. Okay. So, for instance, yes, if x is equal to negative 2, right? I'm like, oh, that's 1 over 0. And that should be an asymptote, right? However, if I plug that in up here, I actually get 0 over 0. And now, this is like kind of like confusion, like what's happening, all right? When that happens, what you want to do is you want to do algebra. So you want to try to like break this up. And so I can notice that this is a difference of squares. So I can write this as x plus 2, x minus 2. And then this thing here cancels with this thing here. And so now all you're left with is equal to 1 over x minus 2. So now suddenly the vertical asymptote of x equals negative 2, that's gone. Right? That doesn't exist anymore. This is called a removable discontinuity. Yeah, so this is what we call like removable discontinuity at x equals negative 2. HHH says, you made that shit so easy. Oh, you showed your friends. Nice, yeah. I tell you, you know, the best algorithm you can get is for like friends to tell friends, or like that's the best way for like reputation or trust. Yeah, all that's good stuff. Yeah, go tell all your friends. Alif says, should I start Feynman lectures? I can do high school math. Yeah, Feynman lectures are great. He's a cool guy. I like Feynman. He's a legend also at Los Alamos. X and Y intercepts. Cool. How do you find an x-intercept, 1K? What's the trick? And then, like, how do you find a y-intercept? Good. Yep. Set it equal to 0. Yeah. So if you want to find an x-intercept, you say y equals 0. If you want to find a y-intercept, you set x equal to 0. So this one's easy, because if you have 2x plus 3 over x squared minus 4, this goes away if it's 0. This goes away, and you get 3 over negative 4. So the x-intercept is at 0, comma, negative 3/4. You need to make sure you write this. The intercept is a point. Don't just say it's negative 3/4. You have to say like 0, comma, negative 3/4. And then for this one, 0 equals 2x plus 3 over x squared minus 4. This is easy, because you can multiply that up. That goes away. And then you're just looking for where this equals to 0, and that's at x is equal to negative 3/2. Or, yes. Okay, so for this one, it's going to be negative 3/2, comma 0. Or y equals 0, x equals 0. Describe the end behavior. Ooh, this is limits. So we want to know the limit as x approaches infinity of 2x plus 3 over x squared minus 4. The easy trick here is that if the highest power on the denominator is bigger than the numerator, then this just always goes to 0. That's like a trick you learn. If you actually want to do it with limits, what I like to do is divide by the highest power of x. So I'm going to divide the top by x squared. I'm going to divide the bottom by x squared. And so that's going to get me 2x over x squared plus 3 over x squared divided by x squared over x squared minus 4 over x squared. Like, let's simplify this. So this is 2 over x plus 3 over x squared over 1 minus 4 over x squared. And the reason why I'm doing this is that, so when you have limits, the first thing you should always check is just put infinity in and see what you get. The issue there is that I would get 2 times infinity plus 3 over infinity squared minus 4. And this really just equals infinity over infinity. And this is undefined. We don't know what this is. So when this happens, Jeff has the formal way is you could do what's called L'Hopital's rule. That's calculus. Or you can do my trick of just see where the exponent is the biggest and like doesn't have square roots on it. And that's this one. And then just divide everything by that square root. So then you get to here. And now what you do is you take the limit as x approaches infinity. Yeah, I know, right? Just plug it in, dude. I treat infinity as a number. Wait 1 sec, sorry. Yeah, because now all I do is I say, okay, this is 2 over infinity minus 3 over infinity squared over 1 minus 4 over infinity squared, right? And anything divided by infinity is 0. So this goes away. We don't need this. We don't need this. We don't need this. And you just end up getting 0 over 1, which is just equal to 0. And so this tells you that y equals 0. As, yeah. Math people do get mad at me. They're just like, no. They're like, what is this? You can't do that. I tell them it works.
What the fuck is this piece of shit?
Anyways, cool. Good question, 1K. Oh, there's my claps. There we go. What if the numerator and the denominator have the same power? The trick still works. Yeah, no, it still works though. You end up getting the constants out, which is cool. Yeah. Okay. All right. Now, Ethan. Ethan, what's up? You here?
Hello.
All right, cool. Oh, lots of questions about banks and rivers and stuff, right? When you look at the speed of the river, you estimate it's about the same speed as you're able to swim. Oh, that's cool. Okay. But
I wanted to talk about something real quick.
What's up? What do you want to talk about?
I don't mean to get off topic, but I've been recently playing. It was like a year ago since I last played Fortnite. I'm just getting back on. I kind of enjoying the new season.
It's great, dude.
But I'm still confused. I'm still confused with some of the weapons. With some of the stuff that they have.
Yeah, well, they added like some like dog treat thing that just like does an insane amount of damage. I don't know what it is. It's called like, what's it called? Krypton something.
Crypto tree.
Yeah, bro, we got wiped by that last time, didn't we? 1K when we were playing that game. We got wiped by the fucking crypto treats. Yeah.
Okay, but let me just dive first. Let's do the question.
Yeah, you're good, dude. Okay. All right, so here's the waterfall. You don't want to hit that. All right, Aleph, you're good. Okay, you realize... okay, sorry. You realize that you can only swim so far in the cold water at the speed before your muscles shut down. And in still water, you estimate this distance is about 100 meters. The width of the river is 80. Okay, cool. That's so interesting. Okay. So this is 80 meters, right? And we're saying that when I can, yeah, the most distance I can spend in the water is 80 meters. Okay, cool. All right. So that means that this distance, right? Or sorry, 100 meters is the most you can spend in the water. This is the most this can be. Okay.
You understand the question, or are you just confused?
No, I do. I get it. And then what we're saying is that like my velocity in this direction. Is it the same? Okay, same speed you're able to swim. Okay, so this has to be the same. Okay, cool. So that means that if this is 80 meters, oh, this is 80 meters then. Yeah, okay. So the minimum distance you have to start upstream is 80 meters. Right?
Alright.
Okay. If the river flows from west to east and you start on the south shore, compute the direction you must swim in order to safely get across if you leave from the starting point. Isn't that just 45 degrees?
Is it?
Yeah.
Is it or?
Well, I mean, because you're swimming at 80 across. The stream is pulling you at 80. Oh. Compute the direction in which you must swim. Am I not understanding this question correctly? Maybe not. These things always bug me out, dude.
Bro, really? I didn't mean to stress you out, bro.
No, you're
Didn't
fine,
mean
dude.
that any-
You just killed Ethan.
yeah.
Yeah, this
Oh,
is 80.
he's not.
This is 80 square root of 2 then. But that's more than 100, right? Oh, okay.
80 times 1.41, right? Is the square root of 2?
Yeah, so that doesn't really work, right? Yeah, so I see what has to happen. Okay. So you need to so that's the minimum distance for you to not be swept over by it. But I think now what we're saying is that you have to go at an angle this way, such that you don't spend too much distance. Although I think like time-wise you're gonna spend more time, no? Yeah, you have to swim upstream. Interesting. Okay. Oh well, I think I know. Isn't it just Jeff? Isn't it just this angle then, but like up? The fact that I have velocity vectors and distance vectors that are separate, my brain is smoothing right now.
Is this confusing to you? I could try to find an easier question.
No, I like it. It's fine.
Does this have to do with vectors again, or?
Yes, Taco Cat. Yeah, I'll explain why I made them that way. It's mainly because I know people are just stacking channel points.
Yeah.
Okay. Okay. This is equal to. Let's call this like an angle, right? This is some angle theta.
Wait, that was actually something I just remembered.
What's up?
Remember Sam? Like Sam Plays or something? I can't remember his name.
Playmoats? Yeah, Sam. Yeah, we know Sam. Sam's still around.
Hey, what if he does the strategy that I just remember? He buys a lot of MT or SCP coins at the end of the tournament.
Well, that's why I made them really expensive. They're super expensive now.
Oh,
what's up, Equity? Equity's back.
20k for like 1,100, right?
Yes. Yeah, I made them really expensive. Yeah, I think it's the same thing. But you can actually swim at less than the angle if you start upstream enough. Can you, Jeff? Okay. Yeah, but you need the distance to be less than 100, though, right? So, for instance, if you're going up here at, I don't know, like V, and then this is V. What's up, Equity? Yeah.
My man.
Also because there are so many streams now, Nick. Like, I have my UCLA streams that people I know are just farming points on. There's so many streams. Ugh, my brain's hurting from this one.
Can you hear my keyboard typing?
I cannot hear your keyboard typing.
Okay then. And you're not hearing any noise outside?
No?
Okay. Just trying to make sure. I don't want to Like,
Yeah,
make
right. That angle
background
won't.
noise.
The angle won't cancel out, right? Yeah. Oh. If you swam straight upstream, you'd go at 0. Yeah. Okay, that's cool. To think about the limiting cases, then, right? Yeah. Okay, let's define an angle. Let's define this as like theta. Okay.
Yeah.
So, V sine theta needs to equal 80 divided by the time, right? And then
Yeah.
VT has to equal 100. Or has to be less than 100, right?
But I mean, most likely yes. Most likely yes.
And then, yes. Well, this is in the y direction, so, right? In the y direction. V sine theta has to
And
equal the y direction you travel, y divided by the time. Yeah, Vx equals V cosine theta minus V. Yeah. That'll define our how far upstream I need to be. Right? So upstream equals Vx times t. So then that's going to be Vt cosine theta minus Vt. Okay, so this is all like x stuff.
Alright.
Alright.
Lots of x's.
Okay. Let's just assume Vt is equal to 100. Okay, so I got to spend... because that's the amount I am pushing. Yes, I am swimming V. Right, Jeff? Okay, cool. So, okay, so then Vt sine theta has to equal to 80. So 100 sine theta has to equal to 80. So then sine theta is equal to 4/5. Okay. So the arc sine of that. Yeah, exactly. Yeah, okay, good, Jeff. All right, we're on the same page. Okay, arc sine of 4/5. 53 degrees. Oh, it's a 345. Fucking stupid. Yeah, okay, cool. It's 53 degrees. It's a 345.
That's it?
Yes, okay. It's 53 degrees. And then as for the amount... and then what is this? So 100 cosine theta minus 1. That's equal to the x distance, right? That you have to be upstream. But cosine of 53... Is that going to be 3/5? Yeah. So... Yeah, okay, cool.
So, did I at least try to participate in this a bit? Like, it's my question after all.
Yeah, but I don't think you're going to get this. Because I barely get it.
Hey.
Oh, it's 1 minus cosine theta? Why is it 1 minus cosine theta? Okay, whatever. Let's just believe it. Okay. Because it's upstream. Okay, cool. Okay, so then x is equal to 40 meters. Okay. So you got to be 40 meters up. You got to be going at 53 degrees. Let's see. ChatGPT agrees with the 53 degrees.
I can't see ChatGPT.
I know. I'm just looking at ChatGPT.
Yeah.
They say the answer is 60.
60 meters?
Ah. Okay. It's just 100 cosine theta. Yeah. Oh, I don't know why I wrote this then. Wait. That's how far downstream you'll go. V. Yes. Oh, I had this right. Sorry. No, I had this right. Because my x to the left is negative. Sorry, no, I had this right. No, this is cosine theta minus 1. Yes. Yeah, you're yeah. Jeff bringing me down the wrong pastures. He's like, hey, I'm just here to distract. Okay. All right, yeah. Okay.
X is equal to 60 meters. I get it now. Okay, cool. Awesome. Yeah, good question.
Well, was that a headache for you or no?
It was a little bit of a headache, but I think I got it eventually. I don't know if I could explain it to you, though, because it's a little advanced. But it's a good question. Alright, I got a lot of...
Do you want to give a bond quiz for asking questions?
I give you a question. I give you a question for it. I give you one card for it.
It's talking about SCP coins, right?
I do that at the end of the week.
Oh,
yeah.
Alright then. Also, there is like, it's like, there is like one thing I would want to say, but I rather speak to you privately on a call because it's hard for me to type out.
Okay, that's fine. Yeah, you can DM. Yeah, DM me, dude. You're fine. Aleph, what's your question, dude? I don't see your question.
I ran out of DM because it's hard for me to say it.
Okay, that's fine. Just write it out, dude.
Could I try to like speak it like two of us privately? Or...
Oh, you want to get? Yeah, you can give me a voice. Well, I mean, probably not in the next couple days. I'm super busy with stuff. But maybe.
Right.
Yeah, type it first. Type a brief version of it first, and then I can give you a voice call. It's just my next 48 hours are about to be fucking nuts.
It's alright. Look, you can take all the time you want as long as it's in a couple of days.
Yeah, you're good. Just send me a DM first, and then I'll call you. You're good. Aleph, can you submit it again? Because I can't scroll. Yeah, don't tell me screenshot a little while back. Do you know how many screenshots we have in this Discord? All right, good to see you, Ethan. Yeah. The rule for questions is screenshot today, like now. Because I'm not going searching through my Discord for like days ago. It takes too long. All right. Here, let me do some of Nick's questions. Nick, you've been waiting around for a while. Are you in a game, Nick? Or do you want help now? What's up?
Yeah, I'm here.
Okay, cool. Let's do a couple of yours. Because I want to make sure we do. And then Equity, if you're around, I'll do yours. And then Aleph, when you find yours, send it to me. Cool. Oh, this is kind of cool. All these weird ass questions, dude. All right, we did those three. We did those three. I think we need to do these three next. Let's do these. I think if we get through like 3 questions a day, Nick, we'll be good by September for you.
Yeah.
Yeah. Okay, here we go. 36 officers
questions that I have 2 to 3 pictures together.
Yeah.
Or the messages. That's the ones that are together.
Yeah. I get that. They're related. Yeah. And they also say up here, Nick, they say like questions 13 through 15.
Yeah.
Okay. 36 officers can complete an assignment in 22 days. Assuming all officers work at the same rate of speed, the number of officers that would be needed to complete the assignment in 12 days is... Oh. Okay. I might be dumb on this one, but I think it's like 36. Is this the man hours question? Damn it.
This was very confusing.
Yeah, I know what I'm talking about.
I did 36 divided by 22 and then something else.
I wanted to do this. I wanted to say 36 officers in 22 days has to equal to... No, that wouldn't make sense. It's not going to make sense. Yeah, this is a man-hours question. So, yeah, Jeff says this is a man-hours question. So, 36 times 22. So, this is 36 men times 22 days. Thuma, what's up? What's up, good?
Oh, no.
What's up, Thuma? What's crack-a-lackin', dude? All right, 36 times 22. That's 792 man days. Okay. This is kind of a weird unit, right? Man days? Like, what the fuck are man days? Every day's man day. Or Saturday, at least. Saturday's for the boys. Okay. What this tells you is that it would take one man 792 days, or it would take 792 men 1 day to finish it.
Damn.
Yeah. So let's say, for instance, let's say it takes one man 5 days, okay, to do something. That means a task is 5 man days. Okay? So if it takes one man 5 days, right? Imagine if you had 5 men. Or 5 men, not 5 men. 5 men. You could probably do it in 1 day, right? Because that's the same output of 5 man days. Do you see that? Like, 5 men working 1 day is the same thing as 1 guy working 5 days.
Uh-huh.
Yes? Okay. So, 36 men working 22 days is the same thing as either 792 men working 1 day or 1 man working 792 days. Oh my god, 36 men. Your dream Thuma, right? Okay, but we want to do it in 12 days. Okay, so I'm going to say 792 is equal to some amount of men times 12 days. Women days count more than man days? Are they paid more, though? That's the debate. There's actually a lot of funny studies. There's more women in college. There's more... They're like, I think women have a pretty good advantage these days over men, at least in education. 792 divided by 12, 66.
But they cannot compete in video games.
I don't know. There's some good gamer girls. Except, dude, Nadia's a cheat, dude. What? Found out Nadia uses cheats, dude. And then I got upset, dude. She's on that one website that one Chinese pedophile girl I got busted. No, she's not a pedophile, but she created like an OnlyFans and let like underage people post stuff. I don't know. And then like they're trying to. She's the youngest self-made billionaire or something, and she was co-founder of some AI company. I think it's called Scale AI. Yeah. Okay. What if it's raining men on that day? If it takes 5 men 3 days to paint a room, how long would it take 2 men? Yeah, there you go, Jeff. That's the next question. I don't think he has to do that. Okay. All right. Here, questions 13 through 15 are to be answered on the basis below. Oh, so here's like, I don't know.
This is so dumb.
This is really interesting.
Especially with the numerical increase. I don't know what the hell that means.
I don't know what that means either. Oh, here's what they're saying. Okay. Oh, these are missing. Nick, this is missing. Okay.
Yeah.
So we would need to write. So numerical increase is like how much from this to this. Okay.
Oh, is it that?
Yeah. Do you see how this is missing? This is missing data. Like we don't know what this is, right?
Right.
And we also don't know what this is, and we don't know what this is.
Mm-hmm.
It's like a puzzle. Okay, so you know there was an increase from something up to 529? So that has to be 529 minus 34. See how this is going to be 495? Because 495 plus 34 gets you to 529.
What I did was, for 2007, I did 1,226 plus 38 minus 2,180, and then divided by
No, because you need to know how many court officers there are. Because look, 2180 is the total of all this. All of this is 2180.
Yeah.
Okay, so you need to figure out what this is from here. Because you know this to this has to go up by 34. Now you have the whole column here, okay? Yeah, that was tricky, honestly.
I thought numerical increase was from 40 and lower.
No, numerical increase, I'm pretty sure, refers to this.
It's so confusing.
Yeah, okay. Well, to get the supervisors, you do the same thing, right? You do the 2180, and then you're going to minus 1226. You're going to minus the 495, and you're going to minus the 38. So you should get 421, which is not an answer. Fuck. I do something wrong?
Yeah, I did 2,180 minus 38 minus 1,226 divided by 2, and then...
Oh, they said most nearly.
34.
Oh, no, it's just most nearly. It's most nearly.
I did subtract 34 and I got 425.
Okay, well, you just got lucky then. The answer is
I don't know.
Yeah, I don't know why you're dividing by 2. Don't do that.
No.
Yeah, don't do that. Women are really smart. My mom makes great food. Nice.
You know what's funny? I got 425 and 495 by dividing them by 2
Yeah.
and subtracting one of with 34 and the other one adding 34.
Okay. Damn, the largest percentage increase. Wow, that's a pain. Because now we have to solve for this and for this.
Yeah.
So this is 421. We figured that out, right? This is 421.
Mm-hmm.
Actual Education's Daddy's home. God damn it, Thuma. I can't believe that username's available. I guess it makes sense. Okay. So how do we get this amount then? Nick, how do we get this?
Subtract them all.
Good. Yeah, 2014 minus 40 minus 529 minus 1347. It's not actually my dad, guys. Don't worry. Okay. All right, so then do you know how to calculate percent increase? Do you remember? We did this in one of the earlier questions.
Yeah, sort of.
Okay, what do you think it is?
Something from original
Good.
Minus initial or something.
It's final
Or
minus initial.
Yeah.
All over initial.
Yeah.
Okay, so you got to do that for all of these, apparently. I think you can kind of eyeball it, though. So this is only, like, a difference of 2, and 2 over 38 is really small. This is 34. So watch. We know this difference is 34. So if we do 34 over 495, that's a difference of 6.8%. Okay. 2 over 38 is a difference of 5%. So it's not this one for sure. Looking at this one, right? That's 77 over 421. I think that's a pretty big one. Yeah, that's 18%. Okay, so that's in the running. And then let's look at this one. I already know this isn't going to be. Because this would have to be a difference of over 100 to beat out 18%.
What do you mean?
Because watch, if I do 1347 minus 1226, and I divide that by 1226, that's only like, yeah, about 10%.
The hell?
Yeah. Well, because you're only gaining 100. You're only gaining like 100. You're really gaining like 120. And 120 of 1,000 is basically 10%.
Why is it like that?
Because it's final minus initial divided by the initial.
Oh.
Yeah.
Bro.
It's okay. So I think this one is supervisors as well. In 2008,
Yeah.
the ratio, the number of correctional officers to the other 3 is most nearly. Okay. So they want the ratio of this to this. Well, that's kind of easy because you know all of this, Nick, right? So all of these people here has to basically be this minus this. So that's like 1347 to, I don't know, like to like 1,000-ish. I think it's most nearly 1-to-1. It's pretty close. Yeah.
Yeah, I don't understand how to do the ratio thing.
Oh, okay. So they said the ratio of this to everybody else. All right?
Mm-hmm.
So you could do 1347 divided by, and then that's going to be 529 plus 40. You have Actual Education's mom as well, dude? What? God damn it. To, okay, 1067. Okay, this is a ratio, right? I can divide this down, okay? And that gets me 1.26. Okay? This is the same thing as 1.26 to 1. Do you see how, like, I could write this as 1.26 divided by 1? And this is how you write. If you ever want, like, fractions and ratios, right? Like, 3/5 is the same thing as 3/5. I think you learned this in, like, middle school at some point.
Yeah.
Aleph says, the mean intelligence of men and women is the same, but the standard deviation of women is less than that of men. Ooh, that's kind of cool.
My man.
My man, lol. So yeah, what he means there, that's cool. That's a statistics thing. So that means, like, women are more central around some intelligence, whereas men have, like, some really, like, genius people and some absolute, like, dumb fucks. Oh, that's super funny. Yeah, okay. Alright, does this all make sense? Yeah, good? Cool? You learned some stuff? Nice.
Yeah.
Okay, cool. I'll say this for you.
Later on, there's going to be another question. I want to know if you're going to do it the correct way.
Yeah.
Or there's 2 ways you can do that question.
Which one?
It's another ratio question. Let me show you. Find it.
Okay.
Don't remember how it looked like, unfortunately. That's before this one. Yeah, this one. Save. I'm gonna send it in the
Dude, who submitted this to me? Who's giving me space-time relativity, dude? Chill. Let me see. This one? How do I open this image? Someone gave me this. That's hilarious. Yeah, okay. Yeah, that's the same thing that we did, kind of.
I went on ChatGPT, I got the answer, but it was completely different from the answer in the book.
Yeah, alright, that's okay. We'll go over that one. That's like a double ratio is what it is.
Yeah.
Okay.
Thank you.
Alright, you're welcome, dude. Alright, let me see. Circular spring wave. Ooh, okay, Aleph. A spring constant K. Wait, there's a lot of stuff here. Okay, I'm gonna do like maybe 1 or 2 of these things. Okay. Initially, point P. Both are released afterwards? What do you mean both are released? So, what? I mean, this isn't wave. I mean, this is like, I mean, it is waves technically. This is like nightmare level waves. I don't know what textbook this is that just like decides to hurt people. What's up, Misadventures in Astro? Delta Zeta. Yeah, did you send me this? I don't know how to do this. This is GR special relativity stuff. I don't know how to do this stuff. I don't know many physicists that actually stream that high level of stuff. Yeah, Dirac's. Yeah, it's quantum mechanics. Yeah, I see it. Okay. Okay. Wait, A in the positive extra. So why is A going that way then? What? I'm a mathematician. I do it for fun. That's cool. Whatever, like, you know, floats your boat. In this case, to the left. Okay. Both are released afterwards. Express the propagation of the speed of the wave. Wave speed is... omega is equal to square root of k over m. Wave speed is omega over k, right? So that's 1 over km. K is 2 pi over lambda. Oh, wait, no. Propagation speed is d omega dk, right? Am I thinking about, like, group velocity? Can this question come at the university level? No. This is a graduate level question, for sure. Like, yeah, first of all, like, what? The speed of longitudinal waves on a spring is yeah. At undergrad level, you do not deal with longitudinal waves on a spring. Yeah. I've never seen this before in my life. Why? I don't know. I don't make the curriculum. You just don't. Yeah. Can you treat it as a straight line with a modulus length behavior? Maybe. That's pretty advanced, though. This is way higher than high school, bro. You gave this to a high school kid, dude, he'd commit suicide. Yeah, this is not easy. Yeah, Morin, yeah, mechanics text, yeah. I don't know. This is the type of shit that just like scares people from physics and they never want to do it again. Yeah. I don't know. Sorry, I got to punt on this, Aleph, just because like I have no clue how to do this, and I don't know. I'm kind of running out of time. It's cool though, but I'm not the person to study it with you. I have to use my time to like help people. I can help people with stuff. Equity, what's up? Where you at? All right, nice. Let's do yours. It's a cool problem, yeah, for sure. So, Aleph, if you want to post that in the forum and then have the other people like chew on it, totally cool. We do have some people that are inclined. Dude, I'm that high school kid going to do classical E&M field theory in my university. Yeah, I mean, nice. Good. Good looks. That's cool. You are an anomaly for sure. Most people don't take field theory until they're in graduate school. I never even took field theory, and I have a PhD in physics. Okay, what's up, Equity? Which parametric function could be used to construct the table of the given numerical values? Ooh, this is cool. It's a Moir pattern? What's a Moir pattern? CO, how do you feel about curved space-time quantum mechanics for further gauge theory? Those are all words I know individually. As a group, I don't know what that means. I don't do gauge theory. I don't do 4 vectors. I don't do Lorentzian boosts or yeah. When you take a digital, I see what you're saying. You're talking about this. You're talking about the patterns. GR scares me. Yeah, I don't know. That stuff's like kind of. You think we just guess and check? I feel like there's a way to do this without guessing and checking, though. I really don't want to guess and check. I do have a PhD. Yeah, it's 2 linear functions, right? Yeah, okay. It's so quick to just guess and check. Okay, but how would you do it without guessing and checking? Right? I think you get a relationship between y and x, and then you set like x equal to t or something, right? I'm 35. When x decreases by 3, when t increases by 1. Oh, you can already see it from here. Oh, duh. I'm so dumb. Okay, but let me explain this to Equity, because he's a high school student who actually needs to understand this. Yes, thank you. Okay. So you can set up points this way, Equity. You can say that, like, t is kind of like your x coordinate, and then x here is like your y coordinate, all right? So you want to figure out what x is as a function of t. Yes, plug and chug is a way, but let's say you couldn't plug and chug. So x, in this case, you want to figure out, so x of t is equal to like something t plus like, I don't know, like some like x naught kind of type thing. So I would take 2 sets of points here. So I would say I have -2, 7, and I have -1, 4. And then I'm going to do y1 minus y0 over x1 minus x0. So in that case, that's 4 minus 7 over -1 minus 2. And that's going to get me -3 over 1. Okay? Which is equal to -3. Okay. So now I know x of t is equal to -3t plus x naught. And then you can plug in the point to figure out x naught, right? So you can plug in any one of these points. So I can plug this one in. So I could say x of -1, which should equal 4, is equal to -3 times -1 plus x naught. So in that case, x naught is equal to 1. And so then you have x of t is equal to -3t plus 1. Very cool. I look 25, thanks. So -3t, well, so that's for x. So there's only 2 answers that could be, so it can't be this one. Can't be this one. It could be this one or this one. You do the same process for the other one. And yeah, Jeff is right. If you use t equals 0, this is already the, oh, this is very cool. This is already the intersect, right? This is already the x, whatever, the t intercept, the intercept. So the intercept is 1 for x, and it's 3 for y, so it can't be this one. So that's why this is the answer choice. Does that make sense, Equity? How that works? It's pretty cool, actually. Yeah, nice. Okay, cool. Complete a table of numerical values and sketch the curve for the parametric equations x equals 2t minus 1 and y equals t plus 1 squared. Okay. Oh, I think they just want you to do this. I think they just want t. And then they want, like, x and then y. So, if, like, t is 0, then x is -1 and y is 1. If t is 1, x is 1, y is 4. And so you could keep doing these all the way up to 2, right? So if it's 2, then you get 3, and you get 9. Okay. And I think they just want you to plug the points. So -1, comma 1. That's here. 1, comma 4. 1, 2, 3, 4. And then 3, comma 9 is like way up here. So I'm guessing it looks something like this. Probably, maybe. Yes, you also need -1, -2. Fine, we'll get -1. So -1. This is -3. This is 0. Oh, that's cool. It's actually not. It's actually... Is it kind of like a straight line? What's going on here? -2 is -5 and 1. 1, 2, 3, 4, 5, and 1. Oh. Yeah, it's not centered at 0. Oh, that's cool. The other way to do this, Equity, so if you have x is equal to 2t minus 1 and y equals t plus 1 squared, you can solve this for t. So you can say, well, x plus 1 over 2 is equal to t. And then now you can take this and plug it back into here. And so now you get y is equal to, and this will be x plus 1 over 2 plus 1 squared, which is equal to x plus 1 over 2 plus 2 over 2, right? So that's plus 3. Okay. And now this, right? This is... Shouldn't this be centered at this should be centered at -3/2. Okay, cool, which it is. I guess it's like centered. Oh, sorry, at -3. What am I saying? Yeah, sorry. 1. Yeah, sorry. It's divided by 2. Yeah, 1, 2, 3. Uh-huh. Okay, cool. Yeah, you were right. Yeah, good. There you go. Cool. So that's another way to do it, Equity. You can either make the table, or you can solve for your parameter in terms of one variable, and then slam it back in for the parameter in the other one. Yeah, okay. What's the domain of square root of 2t plus 3, comma, t cubed plus 5? Do they mean the domain of t? Well, I know for this, right? 2t plus 3 has to be greater than or equal to 0. So that tells me that 2t has to be greater than or equal to -3. So t has to be greater than or equal to -3/2. Which means that x, the lowest value x can be is 0. So I think your domain x is just greater than or equal to 0. Right? I think that's it, yeah? Yeah, okay, cool. The domain of f is the same thing, right? It's the same thing. It's related to the domain of t then, right? Oh, the domain of f of t. Sorry, yes, you're right there. Okay, so then -3/2 is, yeah, this. This is the domain. Yeah, you're right. Jeff's right. So f is a function of t. So domain refers to the independent variable, which is t. So what is valid for t? So what you want to look in here is like, where does t not become valid? And it's whenever you take the square root of a negative number. So you just enforce that it can't be a negative number. You're welcome, dude. I love HHH that you brought up the Wheatstone. Let me do this next week, because I have other students I got to teach, like off stream. But this is a great question, HHH, that I will go over when I'm teaching DC circuits next week at my UCLA class. So let me do this one next week, and it'll make more sense to the other UCLA students that are watching. It's a good question, though. Yeah, it's a Wheatstone bridge. It's a cool question, yeah. I don't know. I've been streaming for 2 hours, and I'm mentally gassed at this point. That's why, like, I'm sorry, Aleph, but, like, when you gave me, like, a circular spring with longitudinal modes, I'm just like, no, I'm clocked. I don't have time or patience to do stuff I've never seen before. You're a professor? I'm technically a lecturer. No, professor's, like, it's a whole other thing. But I do teach at UCLA. If you wanna go find me, here, you want to go read my thesis? You want to go read my thesis, dog? That'll be fun. There you go. That link has stuff. UCLA is a beautiful campus. It really is. It is a very pretty campus. It's also in Southern California, which is one of the most gorgeous places in the U.S. besides like the homeless and things, but it's a very the climate's great. You know, smog can be bad sometimes, but otherwise it is I love living in LA. It's amazing. Bro is an aura farmer. That is a recent one that's come up. Isn't UCLA a researching university, so most professors are researching or writing? Correct. Yes. But they do have, and I explained this in one of the earlier streams, they do have what are called teaching professors to try to, you know, solve the problem of researching professors are not always the best teachers. But, you know, universities still teach to undergraduates, and they still have, like, tuition they have to kind of, like, deal with. So yeah, they are starting these like teaching professor things, which I might try to apply for some if they open them up. Yeah. Sebes, I was about to close the stream off. Yeah. No, yeah. Let me do that on Monday, Sebes. That's going to take a short time. Okay, cool. All right. Let's close it out. Thank you, everyone, for coming to Actual Education Office Hours today. Appreciate all the questions. If you're wondering when we're streaming, we have a calendar. Go check it out. That's our calendar. You're very welcome, Femvox. I appreciate you, dude. But yeah, if you want to check out when we're streaming again, let me go find it. I'm from up north, so I was surprised when UCLA sort of caught up to Berkeley. Yeah, UCLA is, I think, #1 in public universities now. It wasn't when I went to grad school there, but it is now. So it's kind of like one of these funny, like, reverse clout chasing thing, because now everyone's like, oh, you have a degree from UCLA. And I'm like, well, we weren't #1 when I got it. So, okay, but cool. Still counts. But yeah, so our next stream won't be till Monday. But if you want help with math, we have some other awesome people on Twitch that do free help on math and science. So Zach has one Saturday morning. And then Penn Center is doing a machine learning kind of read-along thing on Friday. I can do DiffyQ on Monday for sure. Yeah, so if you go to next week, 3 p.m. Pacific, that's when we'll be streaming more stuff like this. So show up early so that you get early in the queue, you know. we get a lot of questions, and I try to do them in the order they're submitted, unless it's a first-time person who's never submitted before. I try to give them a little bit of preference. And also, I have to help out the students at UCLA first, because that's like my paying position job. But you hang around. I'll help you out. Cool. All right. Let's go raid somebody. What's up, Anti-Caffeine? Do I know you? When I got people asking to talk on the stage. State your intentions. Who are we gonna go? Yeah, you're good. You're good, HH. You're fine, dude. Who are we following? Following. Let me see. Volcano Doc is doing stuff. Moohoodles is doing Astro Science Space News. Behind the Science with Dr. Noah Whitman. There's all these cool things going on. What's this guy doing? Is he talking? Oh, it looks like they're talking about something. Let me see who I wanted to read. Yeah. Okay, cool. Here, let's go say hi to Science. I haven't raided them in a while. They're cool. Looks like he's interviewing someone. So, go say hi from him. I will see you guys on Monday. Enjoy the weekend. Stay safe. Peace.